Good morning. My name is Dr. Melanizer, and I want to teach you today about forces and force pairs. Anytime we influence something using a force, we push it, we pull it, we move it and manipulate it, or cause a machine to do the same, we call that the action force. That is us acting on the world around us. There can be more than one action force acting upon an object, but if something is moving an object, trying to push it, trying to influence it, we call that action. The most common action is happening to all of us right now. It's gravitational force. A gravitational force is a natural force in the universe, and that is gravity from the mass of the Earth pulling down on us towards the center of the Earth. That's why no matter where you are on the world, you're always being drawn towards the center because gravity pulls you towards the center. On Earth, within the first 50 miles of the surface, it's 9.8 meters per second squared, meaning if you fall every second, you're going to speed up 9.8 meters per second, going faster and faster the farther you fall. If you want to find your force caused by your weight, you take your mass in kilograms and multiply it by 9.8 meters per second squared. Now, you're probably not collapsing upon the chair or floor you're on right now because that is pushing back up on you. We call this a reaction force. A reaction force is an equal and opposite reaction to a force applied to it. This can be both forces like normal force, which is the force that pushes back up on you as you're resting on something, or it can be equal forces like when you are playing baseball and you hit the baseball with the bat, you can feel the bat lurch backwards as you're applying force to the baseball, the bat is being pushed back. Reaction force is that equal and opposite force when you're applying a force. Now, we call the combination of the force and the reaction force a force pair. Force pairs we use to explore the universe around us. We use force pairs to explore the world around us, and we're going to talk now about how some of those force pairs react. Balanced force is when the action force is equal to the reaction force. The object will stay the same speed, often not moving at all. Now, an unbalanced force is when one force is stronger than the other. If you're playing tug of war and one side has more force than the other, they're going to drag the other group to that side. If you are sitting in a chair and your force of gravity is stronger than the normal force the chair can produce, it will break the chair and you will go through it and the chair will fall apart. When you have an unbalanced force, speeds will change. Typically, things will speed up. Now, when we have an unbalanced force, we try to look for something called net force. And all net force is the leftover force when you take the two sides and subtract them out. In order to calculate net force, simply take all the forces going in the same direction, add them together to one big number, take all the other forces in the other direction, add them up, and then subtract the smaller from the largest, and it will be going in the direction of the largest. Here's an example problem. I have a block that is receiving 3 newtons of force pushing to the right and 2 newtons of force pushing to the left. The force to the right wins. By how much? If we have 3 newtons on one side, 2 newtons on the other, all we have to do is subtract. 3 minus 2 is 1 newton. That's how you calculate normal force. 3, 2, 1. Let's do another one. Now, in this problem, we have multiple forces acting upon the same object. We have 1 newton and 4 newtons pushing to the left, and we have 5 newtons and 3 newtons pushing to the right. 1 newton and 4 newtons are pushing to the right, while 5 newtons and 3 newtons are pushing to the left. Left side of 8 is bigger than 5. 8 minus 5 is 3 newtons. So our remaining force is 3 newtons to the left. Again, just add up the sides together, then subtract the smaller from the larger, and that's it. If you have any questions, here's our emails. Thank you and have a good day.